Hi everyone. It's great to be here in Berlin at Sub0.1. So I'm Adam Dossa. I'm the head of blockchain at Polymath. So Polymath's mission is to unlock global access to wealth creation through a digital economy. So we have a layer 2 protocol on Ethereum, which has been live for around 2 years now. And we've recently announced this kind of new initiative to build a new security token purpose blockchain called Polymesh using the parity substrate framework. So what I want to try to cover today is a little bit about our journey to Substrate, why we decided to use the Substrate framework. I want to talk about some of the kind of design and architecture decisions we've made during that process. And we're continuing to make. And I want to do a little bit of a deep dive into one of the components, which is identity, which is kind of absolutely at the core of Polymesh and what we're doing. So journey to Substrate. So back in late 2017, Polymath was created, was founded, and we had this very clear mission to bring regulated securities and assets to public blockchains. So back in 2017, Ethereum was there. Ethereum was a pretty mature network. There was kind of a great community. There was pretty good tooling. There was some best practice around sort of smart contracts and deploying protocols on Ethereum. So it was kind of an obvious choice, and that's what we did. We've released version 3.0 of our protocol on Ethereum. We're about to release 3.1, and releasing on Ethereum for the last 2 years has given us this kind of great opportunity to kind of get traction, get adoption, and also importantly to learn lots of lessons about the technology, about obviously blockchain technology, as well as the kind of business around regulated assets and securities on blockchains. So what are some of those lessons that we've learned? I think there's lots of lessons. The first is the kind of importance of standardization, particularly to the financial industry. So we kind of led the creation of this ERC 1400 standard, which is this library of interoperable security token standards. And that's seen lots of adoption. We have a bunch of different companies using it, Consensus using it, and many others. So that's one important lesson, was kind of this idea around standardization. Another key lesson or a key insight was this requirement for kind of modularity, flexibility, and extensibility. So, in the regulated world, you have dozens and dozens of different asset classes. You also have hundreds and hundreds of different legal jurisdictions. So if you want to be able to, we have, our mission is kind of to be this global platform, right, which can be used for any asset in any jurisdiction. So if you really want to fulfill that, you have to make sure your protocol is pretty extensible, right? Because it's very hard to anticipate up front every single possible regulation, every single possible law and compliance that may apply to any kind of pair of asset and jurisdiction combination. So that extensibility, very important. Another lesson we learned, right, is that there's a lot of stakeholders. There's a lot of different kind of requirements in the space. So we have spent hundreds and hundreds of hours talking to regulators, standardization bodies, issuers, investors, KYC providers, custodians, exchanges, legal marketing firms, and so on and so forth. So lots and lots of different stakeholders, and they all have requirements. They all have kind of considerations, and over that time, there've been a few, I guess, insights, particularly related to Ethereum, which is obviously where our protocol was based, and around the kind of adoption side, certainly some of the larger, sort of more risk-adverse institutions had some kind of particular concerns around Ethereum and the approach taken by Ethereum. So, and I love Ethereum. We've been working with it for a number of years, but there's this kind of saying, right, that you can please all of the people some of the time, or some of the people all of the time. And Ethereum is very much in the former category, right? So Ethereum is a general purpose platform. It's not optimized for any specific use case. So it's not optimized for CryptoKitties or prediction markets or DAOs or security tokens. It's kind of tries to be general across all of those different use cases. So there's a bunch of design decisions which kind of reflect that and which are really suboptimal for our specific use case of regulated markets and compliance and security tokens. So I'll give a few kind of concrete examples to highlight our motivation to move away from Ethereum towards Substrate. So one of the concerns that's raised, particularly by larger, more kind of risk-averse institutions is if you're executing a transaction on Ethereum, you obviously have to pay a gas fee to do that. That gas fee is consumed or sent to a miner. That miner could be in Europe, it could be in North America, it could be in Asia, but it could also be in an OFAC or a sanctioned country, so North Korea or Iran or whatever your favorite or least favorite sort of sanctioned country is. And for a large institution, which is in the kind of full glare of regulatory scrutiny, that can obviously be problematic. That's one key concern, is that kind of permissionless mining process. Another concern often raised is around finality of transactions, right? So one of the kind of touted advantages of blockchain is that you have this instant settlement. So, you send, if you're purchasing, let's say you're purchasing a security, you send your stable coin, you get your security back in a kind of single atomic transaction, and it's settled instantly. But, in practice, that's not really true, right? So with proof of work, blockchains like Ethereum, or like Bitcoin and many others, what you really have is you have a probabilistic guarantee around that settlement. So, depending how deeply your transaction is buried in the chain, or how deeply the block that it's in is buried in the chain, you have a kind of probabilistic guarantee. And we've seen, some pretty major blockchains. So I think Ethereum Classic, I'll pick on as one example. We have seen block reorganizations of, I think, up to 2 days. A few months back, we saw this massive block reorg on Ethereum Classic. So really, if you're a bank or you're some institution using this blockchain, you don't really have instant settlement, right? You have to really wait, potentially some relatively long period of time, right? In Ethereum Classic, probably up to 2 or 3 days to have that guarantee around settlement. And to really understand that, you have to kind of get your arms around the fairly murky world of miners, mining pools, ASICs, hash power, all these sort of things, and sort of understand that so you can understand what the sort of guarantees you have around settlement and around transaction finality. So that's another problem that's often raised. One last kind of concrete example, which is raised a lot to us, is around forks and governance. So, Ethereum, and I have a lot of respect for Ethereum. They kind of cleave the core devs and Ethereum developers cleave very closely to this sort of decentralized ideology, which is great, but it means that there's always some probability of there being a contentious fork. Maybe it's unlikely. Obviously, there are examples in the past, Ethereum Classic being the obvious one, where there has been contentious forks. Quite possibly, and this is maybe contentious, right? But as we approach Ethereum 2 or ETH 2, there's some probability of there being some more contentious forks in the future. Actually, for crypto-native assets, forks are maybe not a terrible thing, right? You have Ether, you have ETC, they coexist. The market gives both of them a value. But for when you're tokenizing real-world assets, it's more problematic, right? If you tokenize a building and there's a blockchain fork, or let's say a fork in Ethereum, unfortunately, the building itself doesn't get duplicated, right? The building is not forked, so you have to choose a side, you have to choose a fork, and if you have a protocol like Polymath, and you have a whole bunch of asset issuers, and some asset issuers want to go on one side of the fork, some asset issuers want to go on a different side of the fork, it becomes complex to manage. And the advice from regulators and kind of some of the big auditors is that if you're going to use a public blockchain where that's a possibility, you need to have like a kind of governance council or some sort of working group that monitors that risk. And that's a big ask, right? It's a big burden on these types of companies. So these are some of the kind of motivating factors that led us away from Ethereum towards Substrate. Why Substrate? I mean, we've heard obviously a lot over the last couple of days as to the kind of features around Substrate. It gives you all of this great functionality out of the box, but also gives you the power or the kind of option to adjust and tweak that functionality, both at the kind of consensus level, so that right at the kind of basic enabling level of the blockchain, but also to add business logic right at the kind of core level or layer one of the blockchain. So you can kind of add this business logic at the core level, and you can also tweak all the consensus stuff that you need to tweak so that you can optimize it for your specific use case, which in our case is regulated assets. So I'm going to talk a little bit about the architecture of Polymesh. So there's sort of three levels I'll go through. The first is the sort of base level. I've called it security here. I'm not sure if that's the best word. So Polymesh is a public blockchain, but it is also a permissioned blockchain. So what does that mean? There are some some aspects of that. So the first is that every network participant must go through some sort of basic KYC process. So everyone who wants to use the network, who wants to submit transactions to the network, has to go through a basic KYC process. That means obviously that the network has a kind of root of trust in these KYC providers, and that set of KYC providers is managed through transparent on-chain governance. I'll talk a little bit more about the on-chain governance, but there's kind of an on-chain governance process that manages the addition or removal of KYC providers that are trusted by the network. Another aspect is that the validators or block producers, the kind of nodes which are contributing to consensus and producing blocks, are permissioned. So obviously in Polkadot they're not, and by default in Substrate they're not, but in our kind of implementation of Polymesh using Substrate, they are. So this kind of helps obviously address some of the problems I talked about just a few minutes ago. And again, that set of permission validators is managed through transparent on-chain governance. So in terms of the on-chain governance, the way that works, it's similar to, or has some similarity to how Polkadot works and how other blockchains work, but you have there's kind of one part which is token holder led. So if you hold Poly tokens, you can propose new changes or upgrades to the network or inclusion of new KYC providers or validators. And there are also these kind of governance committees who are more kind of federated layer on top of that. So we have this sort of on-chain governance. The next layer is a sort of business logic layer. So we have these runtime modules, or I sometimes call them financial primitives. So the idea here is that you can take key core bits of functionality needed for regulated securities, like identity, key management, regulated assets, settlements, and so on, and have those as runtime modules. It makes them, means they're accessible, they're standardized, they're easy to interact with. You can kind of fix the costs, like the kind of gas costs or transaction costs associated with those. And obviously because it's Substrate, you can upgrade them, you can iterate them as needed. And the last one's kind of interesting. So, I talked about modularity and extensibility. So it's great to have this kind of core business logic as runtime modules, but obviously runtime modules, although they can be upgraded using a network upgrade, that's a relatively heavy process to upgrade a network. It's a relatively heavy process. So the way we've addressed that extensibility is we introduce this idea of smart extensions. So a smart extension is a smart contract which is written in a particular DSL. And it's constrained in some ways. And the idea is that you can have these smart contracts or these smart extensions and attach them or plug them in to certain runtime modules or financial primitives to extend the behavior of those runtime modules. So to give a concrete example, suppose that you have a compliance rule that says you can have at most 100 investors in your asset. You can codify that compliance rule, so codify that you can have at most 100 investors in your asset in a smart contract or a smart extension, register that smart extension with your asset, and then every time you execute a transfer of your asset, it checks with that smart extension that you're compliant with that rule, and if you are, great. If you're not, the transaction fails. And the same logic applies to, say, pricing or STO. So if you're fundraising, if you're selling your asset on chain, maybe you want to set pricing based on tiers, or you want to set it based on timing, or you want to have some sort of auction-based methodology to set your pricing. Rather than us try to build all of that logic in at the runtime level, we allow users of the blockchain to define that in smart contracts, connect that into the settlement runtime module, and then define their own logic, which is then used by the settlement module when people are purchasing the asset. So one reason this is kind of interesting is that when we first looked at Substrate, sort of towards the start of the year, contracts and runtime modules kind of lived in their own universes. So you had the contracts SRML module or palette module now, and you obviously had runtime modules, but there's very limited sort of interaction between those two worlds. So one of the things we've been working with the Parity team over the last couple of months is to help flesh out and bring richer interaction between runtime modules and smart contracts. So that smart contracts can read state from runtime modules and vice versa, and you can kind of interoperate or interact between those two worlds. And that's something which is in progress. I think there was some PRs merged into master a couple of weeks ago. There's a bunch more work coming this month. We're hoping that most of that functionality will be done this month. So that's something which is exciting. I think that it's obviously important for our specific use case. I think that type of functionality really helps to kind of showcase some of the power of Substrate and some of the power of kind of having runtime modules and smart contracts to work with, and how you can kind of use them together to really kind of provide some powerful functionality. Okay, one more slide very quickly. So I think I talked about actually the first two layers. We have our financial primitives, which are basically runtime modules. We have our smart extensions, which are these smart contracts, or these slightly constrained smart contracts written in DSLs, which plug into certain runtime modules to extend the behavior. And then we also want to open up the network to unconstrained smart contracts, right? So that you can start to see these sort of open finance or DeFi protocols come to Polymesh. And DeFi is obviously a super innovative, exciting space. There's a whole bunch of people working on it. We think that there are two constraints to DeFi protocols as I see them today. One is that they tend to focus on kind of crypto native assets and utility tokens, things like Ether and utility tokens. If you can bring regulated assets and start using your Tesla shares or your Microsoft or Apple shares as collateral and so on, that massively expands the kind of scope of what you can do with DeFi and open finance. And the other constraint, the reason that most of these DeFi protocols rely on over collateralization is that you have a sort of Sybil problem, right? So the worry is if you borrow assets on chain, you can obviously run away with those assets unless you're over collateralized. Because Polymesh has this basic KYC process that every participant has to go through, there is some measure of Sybil protection in Polymesh, and we think that also can kind of greatly expand the design space of open finance or DeFi protocols. So that's something we're very excited about. Okay, so I'm going to talk a little bit in more detail about identity. So what is identity? So identity in Polymesh is absolutely kind of core to what we do. So typically in a blockchain, every transaction is mediated through an account, right? A sort of public-private key pair. You sign your transaction, gets sent to the network and included in a block. In Polymesh, every transaction instead is associated with an identity. So every single transaction in Polymesh is mediated through an identity. So what is an identity? An identity is effectively a collection of claims or attestations from other identities. So you can see some examples. This is an example KYC claim here. There are some standards around sort of self-sovereign identities. So the W3C group has some standards around DIDs, which are decentralized identifiers, DID documents, verifiable claims, and to a large degree, we're kind of compliant with those standards. It's an evolving space, and it's we're kind of involved in lots of those groups defining those standards, but we're trying to comply as far as possible with those standards. So how does it work? So something else that's worth mentioning is that all of your assets, so as well as all transactions being mediated through an identity, any assets you hold on Polymesh are held at the identity level, not at the account level. So any poly balances you have, but also any securities or assets that you own are held at the identity level, not at the account level. And last but not least, so there are a few constraints that, because we're operating regulated markets, there are a few that has an impact or adds some constraints to the way identities are managed. So for example, if you want to hold, let's say you want to hold Apple shares, that means in order to hold Apple shares, you must allow Apple to be a claim issuer on your identity. So generally speaking, you kind of control who can issue claims against your identity. But if you want to hold a particular asset, you must allow the issuer of that asset to make claims about you so that they can, so we have this logic which allows asset issuers to manage transfer restrictions based on identities and claims on those identities, and so that the issuer of that asset can kind of be in control of that process, they have to be able to make a claim about you. So for example, if you're an employee if you're an employee of Apple, they would make a claim that you're an employee of their organization. There may be some transfer restrictions that apply as a result of that. So that's identity. The next kind of related bit, right? So if all transactions are mediated through an identity, identities can't sort of naturally sign transactions, right? So you have to have some way of actually kind of controlling that identity. So what does that mean? So the way we've modeled it is that every identity must have exactly one master key. So there must be one account, which is a kind of like an admin account or something like that for the identity. Typically that account will be like a secure account, so maybe generated on a hardware wallet or paper wallet and held off chain and so on, and would interact relatively infrequently with the identity. So every identity has to have exactly one master key. And in addition, you can create and attach multiple signing keys to your identity. And signing keys are other keys that can act through your identity. and they can have kind of constrained roles. So, I think there are some examples down there. So, you may want to create a signing key for your CFO, or maybe a signing key for your COO, which only has a role, only has permission to update the documentation associated with your assets. So they can't, they can't mint new assets, they can't transfer assets, or maybe you want to create a signing key that only has permission to transfer assets and can't do anything else, can't mint assets and so on. So you can define these very kind of granular or fine-grained permissions for each of your signing keys, which gives you the flexibility. It lets you kind of delegate functionality. It lets you kind of create this kind of set of signing keys with very specific permissions. You can manage the security, obviously, of those keys, depending on how the keys are generated and managed. You can have appropriate kind of permissions against them. The other thing you can do with signing keys in Polymesh is that obviously you can have external signing keys, where an external signing key is effectively just a public-private key pair that you sign transactions with, but you can also have other types of signing keys. So one example is a multi-sig. So for lots of different use cases, you may want one of your signing keys to be a multi-sig, where 2 or 3 or 4 or 5 different individuals have to sign off on a transaction before it's executed. So you can have signing keys which are multi-sigs. And then another interesting use case, which is kind of shown up here on the slide, is that you can have a signing key which in turn is another identity. So in this example up here, you have Apple, so the identity on the left is, let's say, for Apple, and the identity on the right is for a transfer agent. Apple may want to delegate certain functionality or certain permissions to their transfer agent. So the transfer agent has their own identity, and Apple can set up a signing key which is linked to the transfer agent's identity, so that transfer agent can then act on behalf of or act through the Apple identity. So it's quite a nice kind of feature, right? It lets you do a few things. It means that the transfer agent has kind of full autonomy and can unilaterally manage their own keys. So, if the transfer agent wants to add a new multi-sig signing key to their identity, they can, and that's sort of independent of the clients for which they're acting on behalf of. So you have that kind of nice sort of split of responsibilities. And it also lets you model different types of organizations. So maybe, some examples, you might have an organization which has its own identity, which has employees that have their own identities in turn with their own claims, and the organization wants to kind of permission or add signing keys for certain of their employees' identities. So it lets you model things like different kind of organizational relationships and so on and so forth. So it's a kind of nice way to represent that type of behavior. So that's kind of key management. So I'll give a kind of quick update on where we are in terms of roadmap. So we've been working, we started working on Polymesh around April this year. So we've been working on it for a number of months now. We kind of completed a proof of concept a couple of months ago. Obviously, as lots of people have said, Substrate itself is a rapidly evolving code base. So that's a challenge, but it's also exciting. It's obviously bleeding edge technology. We're aiming to release the testnet in Q2 next year, so Q2 2020, and then move on to the mainnet in Q4 2020. That's the high-level roadmap. Something else to mention, so we recently open-sourced our code base. So our code base is up there. So if you Google Polymath or Polymath Network and GitHub, you'll see our code base. Lots of the stuff I've talked about today is already on GitHub. Obviously, it's a fast-evolving code base. We have a bunch of engineers working, there's PRs going in every single day, but it's out there. There's a lot of interesting functionality. We use some of the stuff that's been talked about this week. So we use sign extensions to manage this idea of every transaction being mediated through a identity rather than an account. We use sign extensions for that. We're using off-chain workers for certain types of functionality and so on. So lots of kind of interesting use of some of the Substrate functionality is there. One of the reasons I'm excited about working with Substrate is the community that comes with Substrate, and we're trying to give back to the community in some way. So some of the work I mentioned around smart contract and runtime module interaction is obviously all going back into the main Substrate master branch. But we're excited about people taking a look at the code base. We've had a few PRs and a few issues created by third-party developers. So if you're a developer and you're interested in Substrate or Rust and so on, come and take a look. Any good, bad, or ugly comments or issues, we're all super interested to hear from. The other thing to mention is that we are hiring, we're recruiting. So if you're a developer and you're interested in the space, in Rust, in Substrate, in regulated securities, then I think on the next slide, there's some email addresses, or you can come and find me. I'll obviously be around today, but we'd love to hear from you. Yeah, and that's it. So there's some email addresses up there as our website and our GitHub. Come and take a look. We'd love to hear from you. I'm happy to answer any questions. I also have some caps for people who ask good questions to help motivate it. So yeah, so any questions?
So how do you handle kind of the bootstrapping identity trust issue? Like, like someone's like, hey, I'm the Apple issuer, so I can, make claims about this Apple stock. Like, is your company going to do that, or did you find a group of entities that are going to do that? It seems hard.
Yeah, so that's a great question. As you say, there's a bootstrapping issue, right? Because you kind of so the answer is we have the idea is that we will have a set of trusted KYC and KYB, so know your client and know your business service providers, companies like, I won't say the companies, but a bunch of reputable KYC and KYB providers who will be onboarded at Genesis, let's say. Those will obviously be decided effectively by Polymath and ahead of Genesis. Once the blockchain is launched, that set of KYC providers will then be managed through on-chain governance, but there will be an initial set determined effectively through kind of Genesis configuration on day zero, block zero, whatever, of the network.
Hi, very interesting. Have you got plans to become a parachain in the future? What's your view on that?
See, that's a really interesting question. So parachains, parathreads, bridges, etc. One of the big advantages I see to working with Substrate is that, obviously Substrate-based chains, there's a relatively easy pathway to becoming a parachain or parathread or whatever. And interoperability, interoperability is obviously key, whether it's interoperability with Ethereum, where we already have a protocol and a utility token Poly, or interoperability with some of the other DeFi protocols we've seen presented today and stablecoin protocols is important. So it's an area we're looking at very closely. I'd say, we have no immediate plans to do it, but it's something we're kind of tracking very closely. So we're probably unlikely to be a very early adopter, let's say one of the first parachains, but it's something that we're super excited about. We're tracking, we're keeping an eye on. Obviously there's trade-offs, there's security trade-offs, there's all this sort of stuff. So it's something, and you say there are different ways as well, whether it's a parathread, a parachain, or a bridge. There are different ways to kind of get into that interoperability layer. So it's something we're excited about, something we're keeping an eye on. It's not something we have a kind of concrete plan to do on sort of day one of the network. I can't throw that far, but you can maybe come after and.
Hi, can you tell more about your cooperation with Charles Hoskinson and IOHK?
So could you just repeat the question?
Can you tell more? There on the slide, there was you have a cooperation with Charles Hoskinson from Cardano and IOHK. Can you tell more about this? And the second question, where are you based?
Okay, yeah, I can answer both those questions. So Charles Hoskinson, so to be clear, right, we don't have a relationship with IOHK. We have a relationship with Charles Hoskinson. So Charles Hoskinson is one of our advisors. He's obviously a technical advisor, you could say. So he's helped guide our progress and guide our choices towards frameworks, including Substrate and so on and so forth. But it's with Charles rather than one thing that's often a little bit unclear, right? So it's a relationship with Charles rather than IOHK or Polkadot. It's just the sort of Charles bit of that. And he obviously has a great experience. He's launched blockchains, obviously Ethereum and Cardano. So there's a lot of operational experience, a lot of technical experience, a lot of business kind of knowledge and so on that he's he's using to help guide us. You asked where we're based. So we have an office in Toronto and an office in Barbados. Lots of our developers are remote though. So we have developers all over the world, in most continents, we have developers at this point. So we're super kind of open to remote and decentralized working and so on. You can find me afterwards if you have any questions though. Yeah, go on. Yeah, thank you.
Hi. So I was really fascinating about the interaction between the runtime modules and the smart contracts. I understood from your talk that you spent a lot of time on the compliance runtime modules, and I was just wondering, with your smart extensions that are going to allow people to build new types of applications or dApps on top of that, how are you going to manage the compliance of those smart contracts that are going to use the base runtime modules in different ways?
Yeah, so I think that's a great question. I mean, so one nice thing, right, is because you can have rich interoperability between smart contracts and runtime modules and smart extensions. If you're building, let's say you're building a kind of compound-like protocol, let's say on Polymesh, you can, so today on Ethereum, Compound uses ERC20 tokens and so on, right, and Ether and so on. Rather than using ERC20 tokens, you can use our regulated asset runtime modules so that if let's say you're allowing someone to use Apple shares as collateral, you can use like the kind of regulated asset representation of asset shares, which comes with all the kind of compliance built into it and so on and so forth. So because smart contracts have access to those runtime modules and the compliance and all the functionality associated with that, these DeFi protocols can kind of implicitly make sure they're remaining compliant. Now, of course, if you have some DeFi protocol that builds an entirely new kind of representation of assets outside of our runtime modules, and they would lose that ability. But the intention, obviously, the reason that they have access to that functionality is that they can kind of leverage it and build on top of it. Yeah, thank you. I have another 3 or 4.
I guess the simple question is, who are your customers? Who's going to pay for this, bluntly? Is it more sort of the traders or more the asset issuers? Like, which side?
So in terms of payment, so it's a blockchain, right? So we're putting a lot of thought and time. We're actually working with some external kind of consultants or experts in like economics and tokenomics and that type of thing. So we want to make sure that like the economic model of the blockchain is sustainable, is fair, has the right incentives for security and so on. And that is a work in progress, which is why I haven't talked too much about it at the moment. Obviously, we will be talking more about it. In terms of who our clients are, I kind of see it. My view is it's sort of like a 3-sided marketplace, right? You have issuers, so people who have assets who want to tokenize them. So that could be if you have a company or a startup that you want to tokenize, or a real estate fund or something. You have investors, obviously, who want to access those assets, obviously, for investment purposes. And then you have service providers, people like exchanges, custodians, KYC providers, those types of firms that are sort of providing services to participants on the network. In terms of payments, it's a blockchain. You obviously have, there are fees to transact on the network. The fees depend on various, both on kind of gas metering and functionality and so on. And so that's something we're still working through. And then, it's a proof of stake network. So you use, the security is through proof of stake and so on. It's a nominated proof of stake. So those are our kind of key clients. There are, stakeholders slightly broader than that. So we spend a lot of time talking to regulators in various different countries in Europe, in Asia, and in North America. They're a stakeholder, whether they're actively participating on the network, whether they're just pulling data from the network or using it for reporting and so on. One of the things regulators are super excited about, one of the reasons to hold identity on chain, so there are other kind of identity solutions like Hyperledger Indy where identity is off chain. One of the reasons to have identity on chain is it means you can do compliance in real time, right? So you can have identity rules so you can have compliance rules that depend on identity, which you can enforce in real time as assets are being transferred, which is quite, the current process around compliance tends to be auditors come in every 6 months and do a retrospective audit, check whether an asset has been traded compliantly or not. If it's not, issue fines or whatever they do. The beauty of blockchains, bring regulated assets onto blockchains, is you can do all that compliance in real time, upfront, with real time reporting, and that's something that regulators are very excited about, whilst also being regulators, so risk adverse, somewhat, not the fastest moving kind of organisations in the world, but they are slowly beginning to engage certain jurisdictions more than others, of course, but we're starting to see that type of engagement.
Hello.
So I think the microphone isn't working, and I couldn't quite hear that.
Hello.
Okay, sorry. Where is the identity information stored, and how you handle privacy for that?
Yeah, so that's a great information, great question. So identity is broadly stored, so these claims and attestations are stored on-chain, but you can think of them as kind of being markers, right? So we don't store any PII or personal identifiable information on-chain for obvious reasons because of GDPR and all these other kind of data privacy type issues. So, for example, so identity in Polymesh is pseudo-anonymous. You have a pseudo-anonymous string associated with your identity. And the marker will say, this pseudo-anonymous identity has passed a KYC check issued by this particular KYC provider. So there's no PII data. It's more like it's just a sort of marker that's on-chain. But having that on-chain does mean you can do this kind of real-time compliance. And if you have some transfer rule that depends on whether an investor is or whether an identity is accredited or non-accredited or qualified or sophisticated, you can do all those checks in real time on chain.
All right, we've got time for one more question.
Hi. My question is regarding key management. You said one identity, one master key. And when it comes to like decentralized identities and decentralized key management, how would you ensure that a person that is using the service and buying stock from Apple, it's not going to be tracked through that one identity, one master key kind of system?
So you're asking how would it be tracked or?
Yeah, like if it's one identity, one master key, then how does that work with like a decentralized key management system to like preserve users' privacy?
So privacy is an interesting area, and confidentiality is super important, right? So confidentiality and privacy, for regulated assets is very important. It's one of the key concerns of institutions and investors. It's an area that so with confidentiality, Polymath, we're more in the kind of R&D stage. So we have some cryptographers on the team, and we're doing R&D around that. Confidentiality would likely be in the next, sort of version 2 of Polymesh, rather than version 1. We're looking at all of the usual technologies, zero-knowledge proofs of identity, using zero-knowledge proofs to hide the amount and types of assets being transferred. Identities themselves are pseudo-anonymous, so you have pseudo-anonymity kind of out of the box, but for that kind of higher level of confidentiality, that's something we're more in the kind of R&D phase, and for sure we'll be publishing more information, but it's probably a little bit early at the moment.
Yeah, okay.
All right. Thank you so much. All right, thank you so much, Adam.